You know, it's funny how something as simple as doubling a recipe can suddenly make you feel like you're back in math class. The other day, I was trying to make a bigger batch of banana bread, and I realized I'm multiplying fractions here. It made me think about how often we use multiplication, which is what inspired today's deep dive.
Oh, interesting.
We are diving into the world of, you guessed it, multiplication.
Okay, love it.
And get this. Our main sources for this deep dive are actually homeschooling materials.
Homeschooling materials, really?
Yeah.
A lot of people hear multiplication and just think back to memorizing times tables. But these homeschooling materials actually do a great job of highlighting just how fundamental multiplication is. It's a building block for all sorts of mathematical concepts.
And that's what we're going to explore today. We'll see how it pops up in everything from scaling to geometric sequences, even complex numbers.
And what I love about these materials is how they make these ideas so accessible no matter your age or background.
There's even an activity called, get this, skip counting hopscotch.
Skip counting hopscotch. Okay, I have to hear more about this.
They basically have kids hopping on a giant number line to really grasp this idea of multiplication as repeated addition. It's just one of the really creative ways they make learning interactive and fun.
I love that. It reminds me of another activity in one of these lesson plans. Human vector multiplication. Have you seen that one?
I haven't, no. What is that?
Oh, it's so cool. Students actually use their bodies to act out scaling on a coordinate plane. Like they'll double their height or shrink their arm length to show how multiplying a vector by a scalar changes its magnitude.
That's a great way to visualize it. Speaking of scaling, one thing I always found tricky was multiplying fractions and decimals. But these materials actually break it down in such a clear, step-by-step way, even using visuals like fraction circles.
Yeah, fraction circles are so helpful. And they use that example of scaling a recipe. If you need to double it to feed a crowd or cut it in half, it's relatable, and it shows how you would actually use these skills in everyday life.
And they don't shy away from those potentially confusing situations either. They actually address what happens when you need to multiply fractions with different denominators.
What do they say about that?
Well, they introduce this idea of finding the least common multiple, or LCM, using something called prime factorization.
Right. Prime factorization.
It's basically like finding that smallest common ground where those fractions can meet before you even start multiplying.
It makes it so much easier to work with.
Right. And I appreciate that they don't just throw formulas at you. They emphasize understanding those fundamental properties of multiplication, which I think is key for really grasping the concepts. And I really like how they designed that property matchup activity around those properties, where you match multiplication problems to the property they demonstrate. It's like a game that reinforces those key concepts.
It's all about making it fun and engaging, which I think is so crucial, especially when we're talking about something as fundamental as multiplication.
One thing that's really striking me as we go through these is how they go beyond just the mechanics of multiplication. It's not just about times tables and calculations. They highlight how deeply connected multiplication is to so many other areas of math. It's like they're revealing this whole web of mathematical concepts.
And it really reinforces the idea that math is all about patterns and relationships, not just memorization.
And these sources are full of great examples of that, like when they bring up geometric sequences. Remember those? Each term is a multiple of the one before it. It's that classic example of a penny doubling every day. When you see how quickly those pennies start to add up, it really hits home just how powerful multiplication can be.
And they do a good job of explaining the math behind it too. Breaking down the formula for the nth term, a sub n equals a sub 1 times r to the power of n1, and making it actually understandable. It makes such a difference. And then they take it a step further by talking about how some of those sequences converge, meaning they keep getting closer and closer to a specific value, while others diverge, meaning they just keep growing towards infinity.
It's like we're getting a glimpse into the nature of infinity itself, which is always a mind-bending concept.
And speaking of mind-bending concepts, let's talk about how these materials handle complex numbers, because let's be honest, those can be a little intimidating at first glance.
They actually do a really good job of demystifying them.
They do. It's like they're letting you in on a secret. A complex number is basically just a number with two parts, a real part and an imaginary part. And they walk you through how to multiply them using the distributive property, just like you would with regular numbers.
And they even manage to make complex conjugates feel like something other than a mathematical magic trick.
Seriously, they have a way of taking these concepts that seem really abstract and making them feel almost tangible.
They do, which is honestly a real skill. But you know what else really impressed me? how they tied multiplication into something as massive and awe-inspiring as astronomy.
They use scientific notation. It's like the secret code that lets us write out these astronomically large numbers in a way that doesn't take up half a page.
They give the example of Proxima Centauri, the nearest star to our sun, which is about 4.24 light years away.
Which, if you write it out in kilometers, is a ridiculously long number.
But with scientific notation, it becomes a much more manageable 4.24 by narrow 13, much easier to wrap your head around.
And they explain how multiplying those numbers actually isn't that complicated. You multiply the coefficients and then add the exponents.
It's like a cheat code for understanding the scale of the universe. But these materials don't stop there. They even delve into how multiplication affects the behavior of functions, specifically looking at the concept of domain and range.
Right. And this is where things get really interesting because they show how multiplying a number by a constant factor
Yep.
can actually restrict the possible outputs of a function. Like we could see the effects of multiplication rippling through all these different areas of math.
And it highlights how important multiplication is for understanding how functions actually behave.
But one of the most inspiring things I found in these sources was how they connected multiplication to the natural world. How do we see this mathematical concept playing out all around us? They talk about how even understanding basic math operations like multiplication can help us appreciate those miracles of multiplication we see in nature every day.
They even quote a passage about how God can take our meager offerings and through his power multiply them into these incredible blessings.
It's a beautiful way of looking at it, and it really brings home the idea that multiplication isn't just about numbers on a page. It's about potential, about abundance, about the amazing things that can happen when something small is given the opportunity to grow.
And that potential for growth, for multiplication, it's everywhere. From the way cells divide and multiply to create every living organism, to the incredible patterns you see in fractals, those intricate designs that are all based on the simple concept of repeated multiplication and scaling.
It's really quite remarkable when you stop and think about it.
Who knows what other mathematical wonders we might uncover if we keep looking with fresh eyes.
It really makes you appreciate just how much we take for granted, doesn't it? We go about our days and we don't even realize the incredible math that's happening all around us.
It's like we've been speaking the secret language all along without even knowing it.
It's the language of the universe. Remember that quote by Galileo? Mathematics is the language with which God has written the universe.
And it makes you realize that math isn't just this abstract subject. It's the key to understanding the world around us.
And the more you understand it, the more amazing it becomes.
Exactly. And what I really appreciate about these sources is that they don't make you feel like you need to be a mathematician to appreciate all this.
Right.
You don't need a PhD to see the beauty of a fractal or the spiral of a seashell. But once you start to understand the math behind it, it just adds this whole other layer of wonder.
Pay attention to those patterns and relationships in the world around you.
Look at the world with fresh eyes, with that sense of mathematical curiosity.
Me too. It's like we've been given this incredible gift, this ability to understand the universe through math.
It's a pretty amazing gift. Well, on that note, I think it's time for us to wrap up.
I know, I can't believe how much ground we covered.
And remember, math isn't just about numbers and equations. It's a way of thinking, a way of seeing the world in a whole new way.
So keep those eyes open and keep exploring. There's a whole universe of mathematical wonders out there waiting to be discovered.